0.8 diameter strand, either one. The pre-stressing force is transmitted to the anchor, to the concrete through anchorages. These are examples of anchorages: an encapsulated anchor. An encapsulated anchor, that means they're covered with plastic for additional corrosion protection. We use this kind in tanks. These kinds, non-covered, are used in buildings. For the walls, we use multi-strand anchorages, many strands in one duct. These are for one strand at a time. These are 4, 7, 12, and 19 strand anchorages for big tank walls. The type that use this anchor have grout, cement paste injected into them, injected in the tube, and they run through the tube where the steel is encased. These are the anchorages that go along with this type of system, flat duct system, taking 4 or 5 strands at a time. That's a 3-strand for 3/6 strand, or 15.24 millimeter strands. This is a 7-strand tendon anchorage head, same as this one. And this is called a monostrand stressing ram, stresses 1 strand at a time. Stressing means to stretch the steel once it's inside the concrete. Places the steel in tension and the concrete in equal and opposite compression. So that's definition of pre-stressing. Introduction of stress to a structural member with high strength tendons that counteract the stresses resulting from the self-weight and superimposed loads. So you put the load on the floor, these tables and chairs, people put tendons in the floor first to impart stress into the concrete. We put water in a tank, but first we put compression in the walls of the tank so the water doesn't push the walls out. Pre-stressed concrete comes in 2 forms. You can either have pre-cast, pre-stressed tanks. In this case, the cast is made off-site, transported to the site, and then erected. Or we can have post-tension, which is what we're mainly talking about today, which is cast in place on the site. So some principles of pre-stressing illustrated. Here are some everyday examples. A wooden barrel with steel hoops. The steel hoops compress the timber staves together. This is an everyday example of like pre-stressed concrete, only pre-stressed wood in this case. They're very familiar. A stack of books. If you push in on the ends, you can lift all the books together. This is from the compression, creating friction between the books. Works the same way with concrete. So this is a typical floor slab, simple illustration of pre-stressed concrete. Here's the effect of the applied loads. The green arrows represent the loads. They would cause the concrete to sag and crack. All these would be cracks that would normally come into the concrete. In conventional reinforced concrete, you must have these cracks for the steel to work. So there's the effect of the stresses. There's tension in the bottom part of the slab where the cracks are, and equal and opposite compression in the top part of the slab. That's an internal picture of what's going on with the stresses in this situation. So now if we look at the effect of the pre-stressing or post-tensioning, words mean the same. Here's the pre-stressing strand. It's put in a specific shape, low at the bottom, middle at the ends. When you stress this tendon, if you pull on the steel on each end and clamp it off, it puts an upward force on the member, on the slab. That causes this slab to curve upward. That causes tension in the top part of the slab where it's curving upward, and compression in the bottom part of the slab. Now if we combine these two effects in service, we have the loads plus the pre-stressing. What we get is a slab that's raised up a little bit, and the stresses are illustrated over here. There's some compression, not a lot in the bottom, much more compression in the top, and all the tension is carried in the pre-stressed steel. So this is the way each material likes to be. The steel likes to be in tension, and the concrete likes to be in compression, no cracks. That's the way pre-stressing works.
إذا التصوير الله يخليكم يعني ما نحتاج
If